Welcome back, guys. This is a lesson on how to solve problems using properties of parallelograms. So I think my last video was way too long. This one's going to be more of a condensed version. It's going to get to the point. So if you were absent from class, didn't know what to do, you were gone for anything, this should help you get caught back up and allow you to do your homework. So let's get started. Let's talk about a parallelogram. What is a parallelogram? Well, first off, a parallelogram has to be a quadrilateral. So it's got to have four sides. Now with that being said, a parallelogram has to have some things that are parallel in it. That's why we have the word parallel in the word parallelogram. So what you should know is that opposite sides are parallel. Let me go ahead and draw those in. That side must be parallel to this side. And this side must be parallel to this side. So now we have a parallelogram. Well, sort of. What I still need to show you is that not only is it a quadrilateral, not only do opposite sides have to be parallel, opposite sides must also be congruent. So this side up here must be congruent to this bottom side, and then this side over here must be congruent to this side over here. So for example, if this side is 5, well then this side down here better be 5. So not only are these both sides congruent, they are also parallel. Same thing over here. If this side were 10, this side over here has to be 10. So not only is this side and this side congruent, but they are also parallel. So what is a parallelogram? It's basically a quadrilateral where opposite sides are congruent and parallel. So far, so good. Let's go ahead and move on. With that being said, I want you guys to take a look at the following shapes and tell me which of these could be a parallelogram, which ones are not a parallelogram. Well, let's look at this first one. And I know in geometry we're taught not to assume, but for the sake of this example, if something looks congruent, we'll say it's congruent. So if we take a look at the first shape, I notice that it has 1, 2, 3, 4 sides. So I'm just going to abbreviate. So far it's a quadrilateral. Good, I have that working for me. Let me take a look at the opposite sides. It appears that they are parallel. Like I said, we can assume for right now. It appears that these are parallel. It doesn't look like they're going to intersect. So if I were to try to draw a line, a straight line forever, through both of these sides, it appears that they're not going to intersect. So, you know, that looks okay for right now. Oh, let me just erase those. Probably be easier. There we go. So it is a quadrilateral. Opposite sides are parallel. Let's see if opposite sides are congruent. And again, let's just assume, even though we're not supposed to, those appear to be congruent. These sides appear to be congruent. So yes, this is a parallelogram. Let's look at the next one. Is it a parallelogram? Let's count how many sides it has. 1, 2, 3, 5. It has 5 sides already. That's already more than 4. This cannot be a parallelogram. It's not a quadrilateral. And off to our final example. Let's count how many sides. 1, 2, 3, 4. 4 sides. It's a quadrilateral. So far, so good. Let's take a look at our opposite sides. Those appear to be parallel. These appear to be parallel. This side appears to be congruent to this side. They look like the same length. And, oh, don't want to do that. And it appears that this side is equal to this side. And if you don't believe me, let's go ahead and just do this to see if that would be the case. Yeah, they appear to be the same length. So it looks like everything on here is going to work out. So this would also be a parallelogram. Let's move on to the properties of a parallelogram now. The first one is what I like to call the opposite sides theorem. So if you guys have a parallelogram, opposite sides must be congruent. So it's basically what I was going back and telling you earlier. Opposite sides theorem says that opposite sides, let me abbreviate to help you out. Opposite sides of a parallelogram are congruent. So again, some examples. If this were, say, 8 centimeters, then the opposite side would also have to be 8 centimeters. Simple as that. Let's get a little bit more, let's up the ante a little bit more. Opposite sides must be congruent. So let's go ahead and draw something else. Let's say that this were, say, I don't know, 2x. And let's say this side were 4. Well, if opposite sides are congruent, you can make an equation with this side and this side. If they got to be congruent, you would be able to say that 2x is equal to 4. And that would help you solve any type of equation you're given using your opposite sides theorem. Let's move on a little bit lower. And let's take a look at opposite angles theorem. A little too low. Well, just like opposite sides theorem, the opposite angles theorem says it, opposite angles must be congruent. So opposite angles must be congruent. So let's go ahead and throw some numbers in there. If this were 100 degrees, then this would have to be 100 degrees. If this were 80 degrees, this would have to be 80 degrees as well. So basically, opposite angles of a parallelogram must be congruent. But just like I did earlier, I want to show you one more thing. Let's say that this were, again, let's say that's 2x, and let's say that this is 100 degrees. So if you're given a variable, if you're given a set of variables or more expressions in here, you can still solve these problems. Since I know that these are opposite angles, I know they must be congruent. So if I had to solve for x, I would say that 2x has to equal 100 because opposite angles must be congruent. So all I would do is set these equal to solve. Now you're not going to get things that are as easy as this, but this is just to help you clarify. So x would have to equal 50. And if you substitute that back in here, 2 times 50 is indeed 100, so you know you're correct. That is your opposite angle theorem. Let's move on down. Your consecutive angles theorem. Now remember, consecutive angles is just a very, very fancy way of saying angles on the same side or same line. So let's say this. Any two, and again, I'm going to abbreviate just to make things easy. Any two angles on the same side must have a sum to 180 degrees. So that means that if I'm going to call this angle 1 and I'm going to call that angle 2, that means that angle 1 plus angle 2 better equal 180. And that goes for every side. So this angle plus this angle equals 180. This angle plus this one better have a sum of 180. This angle plus this one over here better have a sum of 180. And again, over here. Any two angles on the same side must have a sum of 180. So that's the basic equation you'll set up for that. Last one, bisecting diagonals theorem. Let's take a look at this one. For bisecting diagonals, what you need to realize is that the word bisecting, again, means cuts in half or cuts in two. So the bisecting diagonals theorem says this. The diagonal from one corner to the other and the diagonal that run opposite directions, they bisect each other, or they cut each other in half. So QS would be this diagonal, and then PR would be this diagonal right here. Those are going to cut each other in half. So let's say that QS is 20, and let's say that PR is 16. Well, if QS is 20, this whole line right here is 20, and PR cuts it in half, that means that this must be 10, and this must be 10. Well, if PR is 16, But the blue line, which is QS, if that cuts this line in half, well, that just means that that's 8, and that's 8. So the bisecting diagonal theorem says the diagonals, I'll abbreviate, bisect each other. Or in easier terms, they cut each other in half. So if you had an equation now, because that's what I want to go back to, because most of your problems are probably going to have equations in them, which is good we go over those. If you had an equation, so let's take a look. Bisecting diagonals theorem. If QS was equal to, let's say 20. And we know that just this part right here, MS, half of the line, was say 2x, what would x equal? Well, if QS, if that whole line, the whole entire line is 20, and I know that QR bisects that, then I know that this part should be 10. And this part should also be 10. So if these are bisected, if they're cut in half, that means they must be equal to each other. So I could say that 2x is equal to 10, divide both sides by 2, and x would equal 5. And that's pretty much it. So make sure in class you pay attention to what your teacher has to say today, and that's basically properties of parallelograms. If you were absent, this is something good to watch to help you get caught up, and see you guys next time.